Now let's talk about voltage. In order for charges to actually move through a wire, like this proton here, there needs to be a force that actually moves it. And this force is what we define as voltage. It is the force or the energy needed to move a unit charge between 2 points in a circuit. Voltage is also known as the potential difference. And if we take this example, a very simple circuit consisting of a voltage source and a resistor, and we have 2 points, point A and point B. At point A, there is going to be an electric potential of V sub A volts. Same with point B, where we have V sub B volts of electric potential. Let's say that this voltage source is a battery, a 9-volt battery. And if we have some point A connected to the positive terminal of the battery and some point B connected to the negative terminal, then we can say that the voltage at point A is 9 volts higher than the voltage at point B. This is the potential difference between point A and point B, i.e., the difference between them is 9 volts. We can label this potential difference as V sub AB. The same thing goes for our original circuit, where V sub AB again means that point A has V sub AB volts more than at point B. Back to our battery, since there are 9 volts of potential difference between the terminals, then V sub AB, which is the potential difference, is equal to V sub A minus V sub B, which should equal 9 volts. V sub A is at the positive terminal of the battery, and this is where all the energy contained in the battery starts out. So V sub A carries a value of 9 volts. V sub B is connected to the negative terminal of the battery, which means that it is part of the ground node, and the ground node is always going to be equal to 0 volts. We'll talk more about nodes and the ground node in Unit 2. For now, we have that V sub A minus V sub B equals 9 volts minus 0 volts, which equals 9 volts. And vice versa for V sub BA, which is equal to V sub B minus V sub A, which is equal to 0 volts minus 9 volts, which equals minus 9 volts. Now, because there is higher potential energy at point A and lower potential energy at point B, then moving from point A to point B, the conventional direction of current flow, this would decrease voltage by 9 volts, meaning there would be a voltage drop of 9 volts. And moving from point B to point A would increase the voltage by 9 volts, so there would be a voltage rise of 9 volts. And we see here that the voltage drop is equivalent to the negative value of the voltage rise. Voltage, aka potential difference, is also known as the EMF or electromotive force, because voltage, or the amount of volts there are in a circuit, is what determines how much force is applied to charges to move through the circuit. Now let's take a portion of a circuit where we have some resistor between points A and B. If point A has 30 volts of electric potential and point B has 10 volts of electric potential, then point A has higher potential and point B has lower potential. And so the current would flow from point A to point B, and the voltage drop between them would be V sub AB, where V sub A minus V sub B would be 30 minus 10, which gives us 20 volts of voltage drop. This voltage drop is the potential difference between these 2 points. If point B had 16 volts and point A had 12 volts, then point B would have a higher potential and point A would have a lower potential. And the current would flow from point B to point A. It would flow from the higher potential to the lower potential. And the voltage drop between them would be V sub B minus V sub A, where 16 minus 12 gives us 4 volts of voltage drop. Since voltage is the amount of energy it takes to move 1 coulomb of charge from one point to another, then the formula for voltage is the derivative of energy per unit charge. So dW, the change in energy, over dQ, the change in charge. Energy is represented by the symbol W, which stands for work, which is a form of energy. Energy is measured in joules, and the symbol for joules is J. And we already know that charge is measured in coulombs. So 1 volt is equal to 1 joule per coulomb. This lecture is included in Unit 1 of our electric circuit analysis series, where we cover basic concepts including charge and current, voltage, and power and energy. The formula sheet for this entire unit is available for purchase at payhip.com/EngineerPeer. Right now, all our formula sheets are on sale for 50% off.